All right. Good Monday, everybody. Welcome to another episode of Bitcoin class with Dr. Craig Wright. And what's the topic we're going to learn today, Doctor?
Okay, we're going to discuss a little bit more on the basic fundamentals of using transactions and how they can be implemented to set up a variety of things, including control of Internet of Things type devices, etc. Now, there are a number of misconceptions that believe that you need to hold keys and control them on a device, and that thus a low-powered device won't be able to successfully engage in Bitcoin transactions.
Mm-hmm.
So, first of all, I want you to answer me something. So, if I'm going to have a device that is going to be associated with a key,
Mm-hmm.
why do you think I need to have the key on that device? Can you explain that one for me?
You need to sign something?
Well, here's the question. Why does that device need it? I mean, you've got the argument that that device needs the key so it can be secure. But why do we need that device to have a particular key or even a hierarchy of keys, as in holding the private key?
I mean, eventually it's a key, a digital key. It has to be somewhere, whatever you put it. Oh, it can be it can be also put not in a device, maybe like a if you want to go to extreme paper, you can write it down even.
But why does the device need the key?
It's just storage. Storage.
So if you think about it, the argument about keeping security, etc., has a flaw in that if the device has a key, it doesn't matter that it signs or not. The device just needs to know about the public key that it's taking direction from or viewing. It doesn't need to have it on any things it's communicating with or anything else.
Mm-hmm.
So if we've got an Internet of Things device that is controlled by a command and control type server or something like this, there is no necessity for either of those devices to hold or control a public key. And in fact, if they do so, there is no gain in security. And having it remote, there is no loss in security.
Hold a public key or public key here. Okay.
So they don't need, all they need to know about is a particular key or key hierarchy.
Mm-hmm.
So they can calculate not only a public key, but it's very simple to do certain types of operation with key adding.
Mm-hmm.
It is far simpler and far less computationally difficult than, for instance, having actual signing of a transaction. So I can do a hierarchy of keys and do some simple elliptic curve operations, even partly pre-compute some of those in a way that is provable without having to do the full signature operation.
Mm-hmm. So you're advocating, so does this low power device store private key or no?
No, not at all. That's where I'm saying people go wrong. They believe Internet of Things is difficult for this because it requires that these devices can sign transactions, but they don't need to.
They don't. Okay.
So now, as examples, I mean, there are, if you want to control one of these devices, they could get their firmware, their updates, etc., as long as they know the integrity sound from anywhere on the internet.
Mm-hmm.
You don't care where you're getting things from. As an example of some of the sort of implementations that have occurred in the last decade, Windows now will connect to multiple machines in a peer configuration to download patches.
Oh,
It
okay.
doesn't require that you connect to Microsoft anymore. If there are other machines that Windows can recognize as a Windows machine, it can connect to those and share the updates, saving bandwidth.
Mm-hmm. Peer-to-peer. Okay.
Why do you think that might be secure, first of all?
May not, because yeah, I mean, if you
Well, but it
download
is.
from it is.
So you just need to validate that there is a digital signature from Microsoft that
I
is
see.
secured,
Okay.
that the hashes match, etc.
Mm-hmm.
So,
So
um,
so even if you download from some let's say non-Microsoft.com let's say domain servers, it's
mhm,
good because you have the, for example, checksum or I
mhm.
know hash or even signature.
Yes.
So okay.
So in downloading and checking, you instantly know. Now, if you see a command for your Internet of Things device or you see a new firmware update, you don't need to have that device that is a low powered device on the network, some other device, do that. It could be any machine anywhere that sends to any address that can be scanned for, and
Mm-hmm.
that can just be sent periodically. So, as an example of what you could do, you could have a um, a device that sits in different locations in different areas and broadcasts updates that it sees that are attributable to certain keys. That could be filtered looking at a stream of information using a cuckoo filter to go through even
Mm-hmm.
large blocks of information and just disseminate the headers and the Merkle path to other devices on the network.
Okay. Mm.
So,
So
can you tell me why you want that information?
oh, you want to verify it's is legit, right?
Correct. So, if that information goes out to the machines on the network, and if it has been accepted by miners and we know that it's valid that way, that's all we need to do. We don't necessarily even need to check all of the signatures ourselves.
Mm-hmm.
If we see something like a public key that has been used, uh, it would be feasible to implement and trust that because it has gone into the Bitcoin blockchain already as a validated block.
Mm-hmm.
So even if our device doesn't have sufficient power to validate digital signatures, we could see that there has been a transaction containing a public key that we trust.
Mm-hmm.
Why do you think that would be? And tell me how that could benefit us.
Oh, because you kind of like outsource the signature verification to, let's say, the miners. Because I mean, not talking about the powerful Raspberry Pi you had, but maybe
Mm.
even lower price, lower
Hmm.
power device. They cannot even for signature checking is
Mm.
too expensive for them.
Yeah. So we can set up devices with very simple filters that see a lot of information going across the network. And if you then have something like a TCP dump type stream, it could merely pull out whenever it gets blocks of information that has been validated correct. And it
Mm-hmm.
could check whether that hashes correctly and whether it's been received by multiple miners. It could see whether another block's built on top of it if it wants to be more certain. Um, and all of that can be done on fairly low-end machines. 386 based Raspberry Pis if you really must.
Mm-hmm.
I'm not sure you can even get 386 based Raspberry Pis anymore, to tell you the truth, but
Mm-hmm.
it would be feasible to run something like this on them.
Mm. They're just much cheaper than signature checking.
Hmm.
Okay.
So this enables the creation of alerts and also command and control type systems. So I did a lot of work with command and control servers from the other side of all of this when I was like a decade and a bit ago involved with the other side of malware and botnets. My involvement was from a blue team type um, perspective, where it was finding them and stopping them and controlling the nasty botnet herders.
Mm-hmm.
Now, when you do that, you gain a lot of experience in how these systems work.
Mm-hmm.
Now, we don't need to replicate it for the bad aspects. And implemented correctly, Bitcoin can be a lot more secure in stopping those guys as well, because we could put controls there to remove keys the way that. Uh, do you remember Conflicker?
What is?
Conflicker?
No. What is that?
No. So, okay. So this is just making myself seem old again, but
Okay.
years ago, Microsoft were headed a group of companies and teams who took down a series of botnets called Conflicker.
Okay.
These botnets were controlled over DNS and used a variety of different methodologies to stay active. But in working with the various certs and DNS management teams, they eventually blocked them all and took out the Conflicker network.
Hmm.
Now, the same thing could, of course, happen if someone built a botnet on Bitcoin. The miners could be engaged to stop transactions or reassign them from certain UTXOs,
Mm-hmm.
especially if there was extra information put into transaction data.
Hmm.
So now, to give you an example of some of what you could do, we could put information into the transaction that could be um, sort of unmasked, so to speak. Now, remember we've talked about XOR,
Mm-hmm.
and we've
Yes.
also talked about HMAC type algorithms. We could use both of those to create a series of rolling transaction masks, all of which are very simple to calculate, could even be built very simply into some forms of chip and hardware. That would then allow us to completely sort of control how we see messages. So imagine now that we have a little bit of push data in one of those transactions that we have as an alert to our machine.
Mm-hmm.
How much information can you put into um, just a 256-bit string?
2 to the power of you can encode 2 to the power of 256.
Hmm. So there are a lot of different variables,
Mm-hmm.
a very large number of numbers. So we have different, no, just in that number, we can have a large number of preset states.
Mm-hmm.
That could either be public, in which case people can look at it and see what we're doing, or it could be masked with other information that can be calculated either using a HMAC against the value that we work out to be something else and a XOR mask that can change given certain input values, etc. Um, and then what we can, of course, do now is have register states or other sort of updates changed using these values.
Mm-hmm.
So um, we can, of course, basically put down each of these values means anything.
Mm-hmm. Yes.
That's where people go wrong. They think information needs to be structured in a more understandable manner for humans. When we're talking machine to machine, we can pre-code 0, 1 equals. 1 equals, and we can set
Mm-hmm.
actions against each of these particular strings and variables.
Yes. Mm-hmm.
So, um, which means in a simple transaction, we can issue a lot of information.
Mm-hmm.
So, um, the irony here is you can give very small amounts of information that expand out to a large range of values.
Yeah, it's even 256 bits, right? It's like 2 to the power 256, which is
Hmm. Yeah,
yeah.
even if we whack in 32 bits of information,
Mm-hmm.
plus a mask to help us keep it more secure, etc., then that's 4 billion or 4.3 billion codes.
Mm-hmm.
So we could have a predefined, if I get this number, that's what it means. This number, that's what
Mm-hmm.
it means. This number. We don't need to have 32 separate switches going 1, 2, 3, as some people do. We could actually
Mm-hmm.
have the whole string gets decoded in one manner and equals one particular command, etc.
Yeah.
Of course, that can be equally 10 different commands because this particular number could be those 10 commands.
Mm-hmm.
So there are no real limits on how we can program any of this.
No.
If we consider that we can make any proprietary protocol within the other protocol for our devices, all we need to do is make sure that we can trust the transactions, um, depending on what level of security we need, how quickly we need it, whether we want to wait for blocks to be built on other blocks or whether we want to be able to trust the information straight away. We might want to either verify the signature, which is not an expensive operation. It's rather inexpensive compared to some other things in
Mm-hmm.
um, digital signature algorithms, or we can wait and see whether other nodes, etc., have incorporated this, in which case we know that it's now valid.
Mm-hmm. So just a question. I think this part I've never fully understood. So you talk about on the one hand, it's IoT low power devices. How are they going to monitor, like a Raspberry Pi, monitor the whole blockchain for that filter out specific just events or data? It is interesting. It's huge, right?
Mm. So what we can start doing is having devices such as routers sitting on the edge of the network with filters. Now, you can actually set up filters using XOR and sort of matching algorithms that run at wire speed.
Mm-hmm. Okay.
If you're not making complex rule sets and you just want to say, give me a block of information, that can be fairly much separated in hardware to run at wire speed.
Mm.
Now, what then happens is the router can see everything and then start distributing to the individual networks it needs to get to. That can be
Okay.
broadcast out to all of those, and then you can even have a flood effect. So depending on how you have your network configured, your routers, your switches can then broadcast everything to all of the devices.
Okay. So
So the way to, sorry.
So actually, the router acts as a the point of filtering. It's basically you subscribe to the router for certain
Or you
type of
could
events.
create a IDS type box or a gateway box in Linux. There are some very advanced routing software programs for Linux now.
Mm.
Uh, you can make some very high-end router equipment using Linux boxes if you want to spend enough money. Even if you don't want to spend a lot of money, there are some good things you can do. Cisco does all of this fairly much by default. They have for a long time. Juniper, the same. Other competing platforms are similar. When you look at some of the high-speed InfiniBand equipment, this will do it all at incredible speeds between machines and backplanes. On top of that, you have the sort of what do you call it? Fast Ethernet, super fast Ethernet type stuff, where you have um, 1,000 gigabit type aggregated connections. All of that can still be done at the network level and then filtered out to the relative machines around the network. It can be done at layer 2/3 switching on your network.
No, it doesn't even have to get to the, let's say, the block or transaction level, like application level. It doesn't have to parse
No.
the data, just a raw stream. You can somehow.
Yeah.
Okay.
Yeah. So that then allows you to actually create what I've said are overlay networks. Now, in an overlay network, I can take part of a Bitcoin network and treat it as if I'm really the Bitcoin network and ignore everyone else that doesn't fit my protocol.
Mm-hmm.
So if you imagine the Merkle tree structure and all of that information, that will allow me to prune everything but the transactions I want and the headers. So think of how SPV should work.
Mm-hmm.
And the same sort of thing can happen. So not only can miners prune, but there are, of course, methodologies for creating blocks that will be pruned of everything that is not the type of transaction or protocol you want. So if you remember, we talked about masking and transaction forms.
Mm-hmm.
So an example would be we could have a subnetwork that actively prunes everything out of Bitcoin to be a new form of protocol that still relies on Bitcoin to achieve the security, the payment transfer, etc. So instead of inventing altcoins or other forms of stablecoin, what you end up doing is having a secondary level processing, like miners, but not miners, that offer selective use and access to the blockchain.
So do you think there's a like a overlay network, how you partition, how you like that's almost like a multiplexing? It's going to be at the network layer, just filter out the data package. It doesn't have to parse anything like a blockchain specific, like a blocks or transactions. It can.
I can't say there'll be a way of doing it.
Okay, so
there'll be potentially many ways of doing this.
Because I could imagine this will be, as blocks and transactions grow and bigger, it's going to be, it's like every 10 minutes, you have, let's say 1 petabyte block. It's not easy to process.
Depends on what you're processing.
Let's say I just, a very easy case, right? I'm like a sensor network. I want to get some firmware update, but I only has to be this new firmware has to be signed by, let's say, this public key. So, and the blocks are like petabytes, but I only want to monitor this public address. How does this work? That's just one scenario. How does this work?
So what you can do, of course, is enact something like SPV. Those parts of the network that match your transactions can be sent, and then the header can be validated. So you don't even need to get a full feed from miners. Miners can give you just the headers. You can, I mean, hopefully we'll have it so that that's even more popular in the future, but just a string of headers.
But then how do I like filter this, that almost the block the data stream, so I know this is public key. I can still catch it. It's like because a big haystack and there's a needle there. I'm a low power device, right? How does this two connect? I'm watching for other events.
This is where you can do things like, if we're talking about petabyte blocks and other such things, again, we can go into other layers of network other layers of control systems, other forms of gateway, etc. Now, the other bit to think about here is creating sub-blockchains based on the main system. So if we have a set of nodes that only distribute the types of transactions we're talking about, like SPV, but think higher volume, more of these.
Okay.
Now, only consider, say, scrypt transactions. Tell me how you might go about that.
Oh, I think for now, some people are doing this, but basically they put a unique ID, like a marker there, and then they do like a raw graph, like the graph for the specific pattern, and then if then that's how they filter. I don't know how they can, if they can scale to like, I don't know, terabytes or petabytes blocks.
Some of that, if you match it right, could be done even in hardware and can be done quite quickly. So now, but if you think about it for a moment, everyone keeps thinking we need to have everything interoperating with everything. If I have a selection of transactions that are operating in full SPV mode, why do I need to care about other people's transactions?
You don't.
I don't. So if I am starting sort of injecting chains of transactions that follow a particular set of tokens, then I don't need to maintain all of the history of everyone else's transactions.
No.
I need the headers, and I need a way of attributing those to my transactions. So if I'm a company that is creating IoT devices or doing some sort of Amazon offering to do all this sort of stuff, I don't need to have my own blockchain. I don't need to recreate everything. But equally, I can offer a service to a number of customers. Equally, I can have that competitive. Equally, I can build other forms of peer networks in the way that Bitcoin has. Starting to see what we might be able to do here.
Almost like you are like I wouldn't say call it sharding, but kind of like you filter all the blockchain data based on whatever you are interested in, and forget about everything else.
So we could even construct incentive systems for these subnode things.
Okay, they are providing services. That's what I'm saying.
Yeah, we could pay them, and you could set up any set of rules you want based on this is on Bitcoin. Here is the header. Here is the proof that it is a valid transaction. Do you see how that now makes a simpler form of peer network as a next layer?
Overlay. Okay.
Those devices can send out simplified blocks. So if we're only talking about small numbers of machines and other sort of information that they're receiving, not the entire petabyte, but maybe 10 meg every period of time, because we've got a lot of little transactions in there still, then we don't need to have everything else to validate those. And we can send other parts directly around the network still. So I can have a node that will accept and broadcast and send every transaction of a type. So we talk about SPV in sort of the standard propagation between Alice and Bob and what they need there. So do you want to tell me how we would do all that process right at the moment?
What process?
The SPV process of sort of demonstrating that you have a
Okay.
Merkle path, a transaction,
Okay.
etc.
Yeah, you get all the headers, and then whenever you get a transaction, you also have to have the Merkle proof, and potentially you have to, or you can also get the SPV even for the previous transaction. This transaction is coming from. Yeah.
So in that exchange, Alice and Bob can be limited to only holding their own transactions, correct?
Yes.
So
And Merkle proof and block headers. Yes, but it's small.
exactly. So imagine now that we have a subsidiary network, an overlay, and what we're now doing is over a different TCP port to Bitcoin, we now start distributing and flooding out transactions based on SPV and the headers, but we do it to a new group of peer-connected machines. So rather than Bob, imagine now that Bob is 100 different computers that act to filter and distribute and disseminate information. Imagine now that Alice is a set of computers that are low-powered devices and don't want to see the entire blockchain, but want to be able to see parts of the blockchain that others, such as Bob, will disseminate. Starting to understand how this might work now?
In the case of Alice and Bob, now Bob is not like an individual now. Is I don't know, a smaller network of let's say IoT devices. That
Yes. So Bob can be a controller network. They can be machines that act as a sort of a command and control layer. They can be incentivized in any way you can think about. And Alice can now be a wide variety of Internet of Things or industrial Internet of Things devices that take updates, run protocol changes, do actions, etc.
from
Now,
commands of Bob.
yeah. Now, Bob doesn't even need to be the person owning those keys. Bob can be the manufacturer of the industrial Internet of Things device. In doing that, Bob can now take all of the transactions to anyone running over the network, over those devices, sending to those devices. So Bob can, for instance, take a set of transactions from customers that have bought their control devices, like their Internet of Things devices, and broadcast that out to parts of the network that subscribe. Now, imagine for a second that you are a vehicle. You're a internet-connected, semi-autonomous drone type device that has controls given remotely. Now you have a methodology of sending and receiving transactions securely. These can be sent across the network, and you can listen to this aspect of the network.
Yeah, and you can validate. You can check.
You can validate, yes. Now, if you're actively driving, I don't think you'd want to wait 10 minutes to validate, but that's where you could set up things like direct payment channels, but the direct payment channel could be implemented using one of these sort of systems if you wanted someone to remotely drive your vehicle. But software updates could be done automatically, or changes to firmware could be done automatically. And as long as the master sort of vendor was not compromised, then all of the firmware would be not compromised. For instance, if Microsoft were compromised completely and then someone issued against their main central server and actively started promoting malware, as has happened with a number of small companies, there'd be little you could do to stop this. But that's a different level of attack. So someone doing a DigiNotar attack is fairly simple. Even that should have been hard. Someone compromising Microsoft without them knowing, and issuing a lot of malware without anyone knowing, and having the software hash not matching without anyone knowing, that's probably not terribly likely.
No.
And if Microsoft ever allowed that, it would lead to a shitload of lawsuits. So don't expect that to happen.
Okay.
So in the ultimate insanity that is our current world, we have people issuing things like NFTs. And they're doing them to hold IPFS update paths and other stupid things, which is completely insane, but we'll not go into that one. What else could you issue now, given what we've just discussed?
What we can issue? We talk about, let's say, firmware update and is it, what else? Not NFT. I don't know. No.
Well, what does an NFT hold and validate?
Supposedly the title, the property title for the whatever art that is supposed to represent.
Yeah, but that can be anything. I mean, effectively, an NFT is a ownership token, the same way that we had dematerialized shares, etc. So we could now have all sorts of other things, not only firmware, but we could use the equivalent for sending controls. And that could be either broadcast to many machines or selected ones. So think about this for a moment. If I'm a device manufacturer, I can embed different key structures to have different levels of control. So if I use key A, every single machine I manufacture between version X and version Y will update. And that can be built into the firmware, etc. Now, alternatively, if I build in version Z, then that only updates with a different key. Now, further on that, I can have machines go out there and do updates or share information between each of these machines. So what's your knowledge of things like Godzilla and all these other horrible peer-to-peer file sharing networks?
Somewhat usually the BitTorrent. I think that's one. I think I played a little bit. Peer-to-peer. Legal file sharing. Sometimes not that.
So tell me what the problem is with many of these networks.
Leeching, like a free rider. That's the number one, I could say. A lot of times you don't want to see it. You just want to get from the network, but a lot of times you don't want to see it. So eventually, a lot of like when you download some movies, or you just get stuck at the 99%. You don't have the last 1% because these are like old movies. It's not the viral one, so nobody is seeing it, you cannot.
Hmm.
That's one of the big issues.
So, how do you incentivize people to see all this information?
Right now, no, you don't. You don't have the. You don't have the. I think some
Mm.
want to have some kind of reputation, but as far as I can tell, nobody's succeeded yet.
Well, what you can consider doing for all of this, not just for command and control machines, but in a wide variety of sharing information, would be incentivize people by paying them.
Okay. So basically,
So,
if I get the resource from you, I pay you
mm,
bitcoins, then
yes.
that,
Now,
that'll be
even in a low sort of power device where it doesn't have enough computational power to do a digital signature, you can still pay with signed transactions.
uh-huh. We just
Now,
verify. We can just ask you to verify. We're using SPV.
mhm,
It doesn't.
yeah.
Okay.
Hmm. So if you think about it for a minute, you can pre-sign transactions,
Mm-hmm.
and these can be set up with other sort of outputs in hash puzzles.
Mm.
Now, imagine now that you have a group of people who are sort of distributing information in this peer network.
Mm-hmm.
You can now have hash puzzle solutions in there that will allow one of them to periodically win a bit of money, even though they're competing for the same things.
Mm.
So there could be 100 people distributing um, the old version of Flash Gordon from the 1930s because
Mm-hmm.
someone likes really camp, horrible villains, and they
Mm.
want to see all that junk. Um,
Okay.
I couldn't think of anything else worse. I mean, maybe King Kong from the original, um, and they want to download it and they want to have access.
Mm-hmm.
Um, so they pay, and even if people aren't currently providing, you could put out a request, and people could dig up and turn on their node, or it could
Nice.
even automate.
Okay.
So in doing this, now you have a methodology for incentivizing people to provide bandwidth for you.
Mm-hmm.
It's no longer a case of an unconditional trust-based, like I hope you will be there,
Yeah. I,
because
mm-hmm. For now, it's all altruistic. It's like almost
yeah,
like a like a social socialism
yeah,
kind of thing. Has got
mm.
that kind of vibe. Yeah. And
That works where you know people. You see, market-based things are conditional. And I say conditional because contracts are always conditional.
mm-hmm.
And conditional means you can effectively breach the contract. Uh, there's not the same obligations upon someone under a contract as there are in non-contract negotiations. As an example, there, you don't want to have a contracted form of marriage. I mean, that's where
Mm-hmm.
people talk about unconditional love, or
Mm-hmm.
um, uh, you can't buy sort of religious belief. You can't buy the national fervor that you get in some people,
Mm-hmm.
nationalistic fervor. Um, that is unconditional. It is not about how much you pay or contractual.
Mm-hmm.
It is other things. The parents and children, I mean, apart
Okay.
from a few weird examples, it
Mm-hmm.
should be um, sort of unconditional. It's not
Mm-hmm.
you do this and then I'll love you. If you don't, then I'll.
Mm-hmm.
I mean, there might be
Okay.
examples of that, but it's not how it's meant to work.
I don't think
So,
it's yeah, it's not a contract. I mean, for at least for most people, maybe there's some
well, maybe Roger
special case.
Ver. I'm
Uh-huh.
sorry, honey, but you didn't fulfill your contract last night. So,
Uh, so stop the credit card. I don't know. Okay.
Yeah. But if you start seeing how what we now do is in market-based relationships where we don't know the individual, where there's no sort of forming trust or honor or anything like this, we can start putting a real cost in it. So, and that's what we have in these situations. People think about it as, oh, I want to form a small group where I have trust, but that is never going to occur where you have like anonymous members in a widely dispersed network. That's not how humans work.
Mm-hmm.
And I
So,
know people want to change how we work, but yeah, we work this way.
mm-hmm. So are you are you imagining like there's all this kind of like a peer-to-peer network, let's say a BitTorrent style thing? It
That's just
can
one
be
example.
okay.
I imagine people will make all sorts of things. Some highly controlled, others very loose. Some will be based on voting systems, like even proof of stake, uh, which could be built on top of Bitcoin. You could have automated share voting. I mean, all proof of stake is proof of share ownership.
Mm,
I mean,
okay.
that in reality is what it is. You don't even need to necessarily stake all of the transactions, but um, you could have nodes paid to do that service.
Okay.
So
So
Bitcoin nodes do X, these other nodes do something different.
mm-hmm.
So remember, we also have the fact that you can create multiple forms of sort of authentication, of finalizing transactions, etc.
Mm-hmm.
So a transaction could be finalized only when a certain other hash puzzle is solved.
Mm-hmm.
So you may require both a signature and a hash puzzle.
Yeah, you can.
And that hash puzzle could also be used in payment of nodes. So it could be a pay to anyone type transaction based on one, the transaction being processed correctly into the blockchain with this extra information added, and then your node finds the other hash puzzle and et cetera, et cetera.
Mm-hmm.
So all of those types of rules can be built into Bitcoin and then sub networks on top of Bitcoin.
Mm. Since we're again talking about like a sub network or even overlay, do you
Mm-hmm.
want to talk about the filtering part, like using like let's say you mentioned one example, a Kuko filter, and
Mm.
somebody else using the balloon filter, or do you want to
Yeah.
cover the filtering side? Usually, how that is done when, especially when the blocks and the transaction volume keep growing. I think at one
Um,
point it can be like a
Given that we only have 10 minutes left, let's
uh,
leave that till next week to go into in detail,
mhm,
and we can start talking about that. But what I want you to get thinking about now is um, we can extend out all of the transactions we're doing by having separate transaction streams that different groups of nodes react to. And they can be things as simple as imagine you have an electronic door.
mhm,
Now, that electronic door could be updated and then the information recorded by monitoring a subset of the network.
mhm.
So it doesn't need to monitor the petabyte blocks.
You cannot.
They could, no,
Yeah,
it won't. But they could
there's
be
no.
the equivalent of a Ring type doorbell company
Mhm,
that offers their hardware products, does the firmware maintenance, has the contracts, and simultaneously filters the primary Bitcoin blockchain to only provide across a subset of all of that a set of information for their machines.
mhm,
They may not even know which particular device is at which particular location. For instance, they could know that this is a Ring doorbell or a Ring door lock, but not know that it is mine
Mm-hmm.
and not know where it's installed.
Mm-hmm.
And I could then just monitor the network as a subset of the network and see updates and changes.
Okay.
And when I see one that matches a key that I recognize, then I act. I either unlock the network,
Mm-hmm.
like open the door, or provide a link to a video conference and give the information where that's going to be connected to, etc.
Okay. So it's almost a Ring, the company, either directly
Mm-hmm.
monitor the whole blockchain or subscribe to some other service that
Yeah.
monitor, only grab the transaction that's
Mm-hmm.
related to all the Ring
Yeah.
devices, and then
Mm-hmm.
keep pushing them downstream to each
Mm-hmm.
individual devices. Okay. So
And it could be even filtered by geographical location. So
I see.
this could be Ring USA, this
Mm-hmm.
could be Ring UK,
Okay.
and I could make it so that Ring USA doesn't work in UK
Mm-hmm.
because I want to be a complete asshole and have differential pricing.
Mm-hmm. Mm-hmm. So how? Okay, just trying to double check. So how is this better than the current one? Because for my current one, I have some Ring devices or let's say even cameras. I just use my app. I don't think it's going through the Bitcoin blockchain, but I think it's not as secure, right? Is that the main?
Well, if anything gets hacked or there's a compromise, um, what record do you have?
No, maybe
None.
they keep like,
So,
I don't know,
yeah,
24 hours or something, but
exactly.
it's
But
gone.
you don't have any way of validating it over time. So if there's been a compromise, the first thing hackers do is they start deleting and
Deleting.
pruning logs that
Mm-hmm.
they've been involved with. So none of that can occur. Um, you know now if there has been an attack, and knowledge of an attack is valuable in itself and also helps provide more security.
Mm-hmm. Do you think this is like uh, it's even enough for like just regular folks, like average Joe, to use this kind of thing at the home, or you think it's like high security, like a, I don't know,
Um,
pipeline or
No, I mean,
wire
it can
share?
do both, but why, if you don't have any cost differential, would you want to limit people's security for the sake of limiting their security?
Okay.
If you can make it so that every bit of firmware is validated, then that's going to reduce a lot of the attack surface that is out there for everyone else as well and make everything more secure. Right now, there are many insecure, vulnerable machines. If we could start looking at those and having them known and be able to trace them back and isolate them and know when things should and shouldn't be patched and all this other stuff, then we can start actually monitoring the security of the network as a whole, improving the security of the network as a whole. And if you start thinking that botnets are really home users who haven't patched
Mm-hmm.
routers, who haven't,
Mm-hmm.
then all that can start being automated and improved. We can ensure that all these devices stay up to date. It doesn't need to be a difficult process because we can automate the update, knowing that it will pull it from a machine out there, validate the full software and hash before it loads it, etc.
Mm-hmm. Okay. Yeah, sounds will not be too expensive if scales up. So it's just
Mm.
like buy another Ring
Yeah.
doorbell or camera.
Mm-hmm. Yeah, and then we can start actively paying for the use of the devices over the same methodology. So, as an example, now your Ring device, rather than having to give it the money to pay for its own activity, I can pay from my phone.
Mm-hmm.
So I can, the same way that you enroll a device right now, what I can do is enroll it against my account, and my wallet could now have the different Ring devices, or I mean, any other brand. I'm just picking on them because I don't actually know who they are. Um, and I could then enroll each of those keys. The Ring device itself doesn't need to ever keep any money.
Mm-hmm.
I could have it and control it on my wallet, and the key that it's associated with, I can pay and keep it going and keep it active and keep the control. So you can segregate the payment and the control and the device itself and the management of the device
Mm-hmm.
uh, completely separately.
Okay. Yeah. For now, each time I get like a smart device, I has its
Mm.
own stuff, like a
Mm-hmm.
payment and app
Mm-hmm.
to control it, like have a Nest,
Yeah.
similar to that, right? It has
Mm-hmm.
its own app and
Mm.
payment and everything. So yeah,
Yep.
if this can be all interoperable to manage it by the
So,
same wallet, I could see
mhm.
benefit. Yeah.
So an example of something is if I had a laptop or a phone, I could require that every week maximum, if not every day or however I wanted it to be, that it goes out there, and anytime it's connected to the internet even, I check the blockchain to make sure that the UTXO associated with my device has not been spent.
Mm-hmm.
If the transaction is unspent, if I try and check from some other server and I don't get a um, evidence of that transaction being spent, I keep running.
Mm-hmm.
If I don't have a check, I stop. Or if um, um, the transaction comes back that it's spent, I stop.
Mm-hmm.
Now, if you attack that laptop or that phone, you steal it, you hijack it, you pickpocket, then I now have a way of remotely turning it off. That can be
Okay.
built into the hardware on the phone, and the decryption key for the phone could require that I connect actively to the blockchain and check a transaction.
Okay. Then it's almost impossible to to just control the phone because it's
Yeah, so
almost
if
like
someone
a.
stole your I'm sorry, iPhone,
Mhm.
you could have it remotely bricked.
Mhm. Okay. You know what? Just have a quick thought. Maybe you can, I don't know, propose this to Elon Musk about when upgrade the Tesla 3 firmware. You can just make it
On the
more
road
secure.
while driving.
Yeah, more secure. So maybe
Yeah,
he would be
exactly.
interested. Yeah, for
Yep.
now, pretty much, I don't know how secure it is, but every time when I drive my car, it says update. I just click yes. I don't know whether, I hope it's safe enough,
Mm,
but
yeah.
I don't know. So,
Mm. All right. So
okay,
we'll go over filters next week,
okay,
and start discussing that and how we can build devices for that part of it. Alrighty.
mhm. Okay, all right.
All right.
Okay,
Have a
nice
great
talking.
evening.
All right, you
Catch you
too.
later.
Thank you. Take it later. Okay, bye bye.